Okay, welcome back. Today we are going to actually do a little introduction and do task number 9. Task number 8 involves launching gummy bears using popsicle sticks, pencils, and rubber bands in the classroom. So we're not able to do that. So we're going to skip that one and move on to number 9. But before we get to number 9, there's a little activity that we're supposed to do. This is supposed to be a card sort. But again, we don't really have the capacity to do that under the circumstances. So I'm just going to sort of go through an abbreviated version of it with you. So what we have here is 4 quadratic functions. Y equals x squared minus 6x plus 8. Y equals x minus 6 times x plus 8. Y equals x minus 6 squared plus 8. And y equals negative x plus 8 times x minus 6. And then we have 4 graphs, and these graphs don't match necessarily vertically like that. I don't know what this little thing is. Let's get rid of that. So what we're trying to do is we are trying to, oh, maybe they do match. 6, negative 8, 6, no, they don't match. Or do they? This would have a vertex at, no, that does not match. X coordinate would be 6, Y coordinate is 8. Where is that? Oh, that must be this one. Okay, I guess that's what we're trying to figure out. Okay, so we've got to use the fact that these 4 functions match with those 4 graphs to figure out the coordinates of some points. So let's see who is who. So the first thing that we should recognize here is that 3 of these open up and 1 of them opens down. And because of that, it's easy to figure out that number 2 is the graph of function b, because that's the only one with a negative in front. So once we know that, then this tells us where this function crosses the x-axis. Since we have x plus 8, then this has to be negative 8, because remember inside the parentheses is always opposite. And then since we have x minus 6, then this one has to be 6. So now we know the coordinates of point Q. That would be negative 8, 0. So that bad boy is done. Alright, now let's take a look at the other ones. So this form of the quadratic tells us what the y-intercept is. So we're looking for one that has a y-intercept of 8. So that could be this, it could be this, but it could not be that, okay? So let's just keep that in mind as we go through. This guy right here has a y-intercept of 6 and negative 8. Well, this doesn't have a y-intercept of 6 or negative 8, no y-intercepts at all. This one cannot have a y-intercept of negative 8 because both of these are on the positive side, so that means that this guy must be function b. And that means that this is negative 8, and this is 6, okay? Alright, so this is a little trickier. This is asking us now to figure out what the coordinates of point S are if we know that this is the function. So what we need to do in order to figure that out is we need to plug in 0 for x, because all along the y-axis that's where x equals 0. And the answer that we get when we do that will tell us what this y-intercept is. So if I go back up here to this function and turn this into a 0 and turn this into a 0, then that's negative 6 times 8, which is negative 48. So the coordinates of point S are 0, negative 48. So you can see that these graphs have intentionally not been drawn to scale, so you have to do math to figure it out. You can't just eyeball it. Okay, so now we're left with just these two. This one is in vertex form. This tells us that the x-coordinate of the vertex is 6. And this tells us that the y-coordinate of the vertex is 8. And so that can't be this one because this vertex is below the x-axis, so it would have a negative y coordinate. So that means that this one has to be graph C, and that has a vertex again at 6, 8. So we just figured out the coordinates of point P are 6, 8. Okay, so that means the mystery is solved. This last guy here must be graph A. And again, all we know from this graph is that it crosses the y-axis at 8. Okay, so the way that we need to then figure out what this point is we need to take this and factor it. We need to write it in factored form. So I don't know if you all remember how to do that, but what we're doing in that case is looking for two numbers that multiply together to be 8 and add together to be negative 6. So I'm going to go with negative 4 and negative 2, because negative 4 times negative 2 is positive 8, and negative 4 plus negative 2 is negative 6. So what that tells us is that this crosses the x-axis at the opposite of these two numbers. So it crosses here at 2, and it crosses here at 4. So that means the coordinates of point R would be 4, 0. Okay? Alright, next one, it says the graph of a quadratic function has a y-intercept at 0, 5, and a minimum at 3, negative 4. Write the equation for this curve. So, to find the equation, since it's given us the vertex, what I'm going to do is I'm going to say y equals a times x minus the x coordinate of the vertex, which is 3, squared, plus, which is minus in this case, the y coordinate of the vertex, negative 4. And then to figure out what a is, I'm going to use this point right here, 0, 5, plug that in there and solve for a. So if I plug in 5 for y, then I get 5 equals, now I'm plugging in 0 for x, so 0 minus 3 squared minus 4. So then that gives me 5 equals 0 minus 3 is negative 3. Negative 3 squared is 9, so that is 9a minus 4. And then I'm running out of room, so you can figure out if I added 4 over here, I'd get 9, and then 9 divided by 9 is 1, so it turns out that a equals 1. So my equation for that is just simply y equals x minus 3 squared minus 4. Okay? Okay, then it says write the coordinates of the roots of this quadratic function. The roots are a fancy word for where the graph crosses the x-axis. So in order to write it that way, to figure those out, I have to switch this to factored form. But in order to switch it to factored form, I first need to switch it to standard form. So the first thing I'm going to do is I'm going to take this and I'm going to FOIL it out. So if I go x minus 3 times x minus 3, we would go through this in more detail if we had time in class. That would give me x squared minus 6x plus 9. And then I still have that minus 4 hanging out on the outside. So now if I combine the like terms, the 9 and the minus 4, that gives me x squared minus 6x plus 5. So again, to figure out where that crosses the x-axis, I need to factor this. So I need two numbers that multiply together to be positive 5 and add to be negative 6. So that's x minus 1 and x minus 5. So that tells me that the roots are the opposite of these two numbers. In other words, it would cross the x-axis at 1 and 5. That was a lot to take in there on that one slide, wasn't it? Some serious math going on there for the one person out there in the universe who's going to watch this video. Okay, so these are the three different forms. The standard form is just written all out regular. Factored form is factored with parentheses, and then this is the completed the square form, or a lot of times you'll see this called, the word I've been using is vertex form. So I think I'm going to just keep calling it vertex form because that's what you'll usually hear. Okay, so what we get out of this is a different thing for each form. So from standard form, you know the Y-intercept. And the Y-intercept is 24. It's the number that is just hanging out here all by itself. From factored form, you get the zeros, or the x-intercepts. And in this case, it's factored into x equals -4, x equals -6. These are all the same, by the way, just written in the different forms. So in this case, the x-intercept would be, it would cross the x-axis at 4 and 6. And then finally, in vertex form, you get, not surprisingly, the vertex. That's why it's called vertex form. And that would be the opposite of this. So since it's x minus 5, that means the x-coordinate of the vertex is positive 5. And then this, so 5, -1. So that's actually the same equation written in the 3 different ways, just to show that you get different information depending on the way it's written. Okay? Okay, so if we were to look at this, y equals -x plus 4 times x minus 5, and y equals -2x plus 4 times x minus 5, you can see that there are some real similarities. So the same is the x-intercepts are both the same. -4 and +5. What's different is since a equals 1, in one of the equations, or yeah, -1, and a equals -2 in the other equation is, that means the graphs will have different widths. So since the a values are different, the graphs have different widths.